All right. Welcome to Thursday, week 6. We hit the halfway point basically yesterday, but we are more than halfway through the material because we have chapters. Oh, this is the wrong one. I opened the wrong one. We'll get the right one. So we have chapter 7 to finish up. So the second half of chapter 7. Where is Thursday, week 6? It's just gonna have to do. Okay, so we're finishing up chapter 7 today. Next week we have chapter 8. Then we're just going through chapter 10. So we are more than halfway done. Is that gonna work? Yeah. Okay. So it's really nice. I'm super excited. All of the most fun math starts today and then goes through the rest of the term. Chapter 10 to me is the most useful, my favorite math. Not super useful to everybody else, but I'm just the kind of person that loves that kind of math. So today we're going to find and interpret the area under a normal curve. We kind of talked about it in 7.1. And then we're going to find a value of a normal random variable. So given the area, we're going to find the value that goes with that area. Today will also be another short class, not quite as short as Tuesday, but it'll still be fairly short. And I have one of the homework problems pulled up because it's the one that tends to give people the most grief. So I wanted to go over how to do that as well. So that'll be at the end. All right. So we already did z-scores. We did z-scores a while ago, and it tells us how many standard deviations something is from the mean. So sometimes we convert things to standard normal distributions. So we will have our normal distribution, which uses our just our regular values. And then we can take the entire distribution and we can standardize it. We standardize it by converting all of the values to z-scores. Don't worry, you're not going to have to do that. But it converts everything to z-scores so that we're comparing apples to apples rather than apples to oranges. And one of the nice things about using z-scores is that our mean is always 0 and our standard deviation is always 1. So this is the really nice thing about standardizing the normal curve, is that our mean is 0 and standard deviation is 1, and it makes it a lot easier to find out where values are and just kind of visualize the curve and everything. So standard normal curve is when we use z-scores with the mean of 0 and standard deviation of 1. A normal curve is when we use the data values. All right. So we've done z-scores before. So I'm just kind of showing you. We just take the data value, subtract the mean, and then divide by the standard deviation. So a person with an IQ score of 120 would have a z-score of 1.33. And I'm sure you all recall any z-score greater than 2 or less than -2 is an outlier, considered unusual. I love z-scores. All right. So we didn't do this part before. Let me show you. So we can use our z-scores to find the area under a curve. So we have z-tables. Just a second. Let me find that z-table for you. So if you go into the assignments and lessons, there's a z-table right here. It might also be in this week's material. Let me look. Yeah, it's also right at the top of this week's material. I'm going to open it up. And then I'm just going to go back to my screen. I'm going to show you. So we have that z-score of 1.33. Using a z-table, I can find the area under the curve, or it's also the probability of randomly selecting a person that has an IQ score of 120. So let's go to our z-table. So with the z-table, in your column right here in this column is the whole number and the tenths place. So our z-score was 1.33. So it was 1.3. And then we go over to the column that contains the hundredths place. So over here, it's right here. This gives us the area to the left of that z-score. So if I was drawing a normal curve, a z-score of 1.33 is about up here somewhere. And then the area under the curve to the left of it is that 0.9082. So the area to the left of the number is what is showing on our z table. If I wanted the area to the right of it, if I wanted the probability that that I would find somebody with an IQ higher than 120. So I wanted to know the probability of somebody getting a z-score higher than 1.33. I would do 1 minus. Since our z-table only gives the area to the left, and it doesn't matter what that value is, you get it. Okay, I'm going to show you the z-table we have. Okay, the z-table we have, as you can see, starts from negative 3.4, goes all the way up to positive 3.4, I believe. So we're looking for 1.33. Okay. So here's 1.3. There's 1.30, 31, 32, 33. It's right there. So this is the same as the z-table I showed you, or it's similar, but this is our z-score and our z-table. And it reminds you in the picture, it gives the area to the left. Let me get back to the screen. All right. Obviously, I also have a lovely calculator function that's going to give us this. We'll get there. I'm going to get there in a couple minutes. The z-table is cool, though. I really like the z-table. And sometimes I just go to it automatically just because I don't want to do the calculator and I kind of like it. But after I show you, you really don't have to go to the z-table again. You can just use your calculator. Oh, look, there's the picture. That's a little better than my sketch. There you go. So if I was looking for somebody, probability of finding somebody with an IQ greater than 120, it would be about 9%. So it's not unusual, but it's still a pretty small number. You good so far? All right. So now we're going to use our calculator. So if I'm looking for, we're going to use an example. So we have this function called normal CDF, and it is our lower score. I'm just going to write it out here. The normal CDF function, it's the lower bound, then the upper bound, then the mean, and then the standard deviation. Remember though, if we're using z-scores, our mean is 0 and our standard deviation is 1. So first I'm going to use the example for the 1.33. So let's go over there to my calculator. All right, look at that. I remembered to put the calculator up first this time. All right, I went too big. Smaller, okay. So to get to the normal CDF function, you're going to hit second, then the vars button, just like we did to find binom PDF and CDF. And it is the second option, normal CDF. We never use normal PDF, never. We only use normal CDF. So go to normal CDF, and we're looking for the area to the left. So my lower bound is negative 1E99. Basically what that number is, I'm going to go back to my other screen. So negative 1E99, what this stands for is negative 1 times 10 to the 99th power. It is a really, 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 really small number. Really, really small number. It's -1 with 99 zeros behind it. So basically it's our infinity. Let me show you where to find the E. Okay, so we're doing -1, get to the negative. The negative button is down here next to the enter key. -1, then you do second comma. So look above the comma, it shows EE. We're just looking for the E. So -1, second E, and then 99. That gives us our negative infinity. Our upper bound is a z-score of 1.33. Because we're using z-scores, the mean is 0 and the standard deviation is 1. And I'm going to paste. Give me a second. So if you're in if you have a TI 83 instead, this is what it'll look like on your screen. You'll do the normal CDF. So it's -1E99, comma 1.33, comma 0, comma 1. Close your parenthesis. Hit enter. And we got the same thing as the Z table. It's just not rounded. Questions on this before you do an example on your own? Okay. So I would like you to try. It's the same thing, but we're doing the probability of finding a Z-score less. Okay. The first number is only going to be -1E99 when you're doing less than. We're going to do a greater than in a minute. So if you're doing less than, it's -1E99 in the lower bound because it's your number down to negative infinity. Okay. So I want you to try this one with a Z-score of -1.2.
How did you get the E?
What was that?
The -1E?
The E is the second. So it's second comma. That gives you the E.
Second.
Did you get that?
Well, on my calculator, the E is green and it's above the sin.
That's a different E.
Gotcha. Okay.
The EE that we have, that's specifically for scientific notation. And I know it's confusing, but it's the E that's with the comma that we want.
Gotcha.
Yeah, no problem. Remember the negative is next to the enter sign. Should get 0.115. We get there? Yes. The two, I mean, mine are blue, but yeah. So it's right there with the comma, the two uppercase E's. Even though it gives you this little teeny tiny one uppercase E, I don't know why it does that, but it's just weird. Okay. So something went wrong. So yours, it should look like this. Okay, let me see here. So when you go to your negative or your normal CDF, make sure it's negative. And this negative is the one next to the enter sign. So the -1E99. Then your upper should be -1.2. You might have done, did you do +1.2 instead of -1.2, Rebecca? Because that looks like that's probably about right for +1.2. We're doing negative. Yep. I was like, that looks like it's probably approximately for negative for positive. Yeah. So I got 0.115. There you go. Good job. Yes. Woo, good job. All right. Normal CDF, love it. I use it so much. I mean, it's gonna carry us through. We got this. You want to write this thing down? Okay. So it shows you right here. You hit second vars. Hit second vars. And then your lower value, if you're doing less than, so it's only for less than, your lower value is the -1E99. And you get this by hitting second and then the comma. Is that the way the comma goes? Yeah. There you go. All right. Cool beans. All right. So now I already told you that if we're doing to the area to the right, we would use 1 minus the z-score we get from our z-table. But I'm going to ignore the z-table for a moment. Let's do, we're looking for the probability that it is greater than 1.3. I'm ignoring this. We're ignoring this. I don't care about that. We're going to look for the probability that z is greater than 1.3. Go back to my calculator. Second vars. Come on, calculator, be nice. Normal CDF. So my lower value is going to be 1.3 because that's my lower bound. I'm looking for a greater than. So I'm going to use positive 1E99. So positive 1, second comma, 99. So the upper, because I'm going above, I'm going greater than. So it's 1.3 to infinity. So my upper is 1E99. And keep your 0 and your 1. Make sure you get the 0.0968. Go ahead and try it with me. So if you're going less than, you're going in the negative direction. If it's greater than, you're going to the positive direction. Are we good? I'm going to have you do one. I'm going to write one on my page just so you can try. I'm looking for the probability, if I can get it to write, the probability that we get a z-score greater than 2.3. That's going to be a really small probability, but that's what I'm looking for. Oh, we will be spicing things up in just a minute. We will spice it up because why wouldn't we spice it up? I like to spice things up. Right now, we're going to do z-scores. So do the probability the z-score is greater than 2.3. So go ahead and do that in your calculator. It's going to be small. Beautiful. You got approximately 0.0107. No negative decimals. You shouldn't have got a negative. Did you do negative 1E99 instead of positive? You should definitely not get negative. Never, never, never. Probabilities can't be negative. No negative decimals, but we got to
Wait,
really.
hold on.
Yes.
I'm wondering if I could show you.
Okay.
Like,
I don't know if I can. Okay, hold on. Okay, put the
it's backwards.
Okay, yeah, it's backwards. Put 2.3 on lower. Put 1E99 on upper.
Oh, okay. Thank
Yeah, swap them. You got this.
I have a question about the calculator.
Okay.
Mine, when I go to do normal CDF or any of the CDF PDF things, I don't have those words that say lower, upper, mu, and all of that. Mine just says normal CDF with the parenthesis and gives me the ability to put the numbers in
So
or the data.
some calculators do that. It's usually because your operating system hasn't been updated, which, I mean, you can do by hooking it to a computer or you just got to type them in. So that's why when I try to write them down on the screen sometimes, so you just have to put them in the correct order. So this would be your lower. The 1.3 here is lower. 1E99 is upper, then mean, and then standard deviation. So you just have to type them in. Which
Okay.
calculator do you have? Do you have a TI 84 or 83?
84 plus.
They do. Okay. I think in mode, let me see here. Do you have math print on in your mode? Hit the mode button. It's a couple of different things that might work. Math print, and then down here, stats wizard. If you have Stat Wizard, you can turn that on. That might fix it also. Otherwise,
I don't see print.
if neither of those does it, then you just don't have a software update.
I don't even see the math print to change it, so, but it is on normal.
Okay, and it's on, the Stat Wizard is on.
Where is it?
Way down here, down to the bottom where it says set clock. I don't know if you have that or not. Stats Wizard.
Stats Wizard or anything. It doesn't say
Okay.
any of
So it's
that.
probably a software update thing. So you're just gonna have
Gotcha.
to type it in after the,
Okay.
yeah, Jennifer, you just have to do the same thing. I mean, all of the math is exactly the same. Yes, so the 2 the whatever value I did, 2.3, it's just 2.3, Clemencia. 2.3 is your lower, 1E99 is your upper, yeah, then mu is 0 and sigma is 1, yes. So you should
I
get,
have a question
okay,
about the z-score. You said on z-score everything is to the left, right?
the table.
Okay.
So
So does that cross over with the calculator then?
no, the
we,
calculator, you're making that determination because
Oh, okay.
I'm saying my lower value is 1.3 and my upper is infinity. So
So that
that's
goes right.
sending it to the right.
I see. Thank
Yeah.
you. Clears it up.
Yeah. All right. We getting there? Doing okay? All right. So now we're going to find the area in between. So if I was looking at a picture of a normal curve, my negative 1.02 is right about here. And then my upper 2.94 is way over here. And I'm looking for the area in here. So what you're going to do in your calculator is it's going to be, of course, normal CDF. My lower value is going to be negative 1.02. My upper will be 2.94. And then we're still doing the 0 and the 1. So this is what you're going to put in your calculator. And we're getting the area in between those two z-scores. So go ahead and give that a shot. So no 1E99s. Because it's in between those two values, we don't need infinity. Let's see how you guys do. I got 0.844 approximately. Yes, good job. You just rounded to one more place than I did. Yes, good. So you should get 0.84449. So about 0.8445, or I just didn't want to round, so I just stopped there. Good job. Questions? Feeling okay so far? Are we ready to take a step into the real numbers? All right. Okay, so now, in the land of stats, a long time ago, back before we had these fancy calculators, everything got converted to z-scores. And okay, everything got converted to z-scores, and we used the tables to find things. Like, I mean, I'm an old lady, so back when I took pre-calculus in high school 1,005 years ago, I mean, it was the 80s, I had really big hair. We had to use log tables. We had to use z-score tables. We had to use all sorts of really crazy things. So, but that was the 80s. This isn't the 80s anymore. So just use your technology. The Z table is really cool and I love it and everything. But if you have data values, you don't necessarily need the z-score, just use your calculator. So we're not even going to go here because we're just going to talk about calculator stuff. So our normal CDF is good. We like that. I thought I had more on this page. I guess I don't. What happened? Okay. So sometimes we want to, hold on. I had data values on here. What happened? Give me a second. I'm mad at my thing here. It's not showing me what I want it to show me. It's just been a week, let me tell you. Bet you this will work better. It's not going to have the fun pen stuff, but it'll work better. The heck? My iPad is okay. Let's do this. Move on. Moving on. Not now. Okay. Thought there was more on that page. We will see. Okay. Yeah, there. So these are how we use our normal CDF. See, I knew there was more stuff on that page. So this would be, so your lower value is always the first one. Your upper value is always the second one. Whatever your mean is. So anything. If you're not using z-scores, you're going to use the actual data mean. The actual mean. And the actual standard deviation. So that's when we're looking between two values. If you're doing less than, you always have that negative 1E99 in the lower. If you're doing greater than, you have the 1E99 in the upper. So this is the standard way we use our normal CDF. Use the normal CDF, please. It's just so much, I mean, the Z table is cool, but use the normal CDF. Okay. Give you a second to write that down. Take a drink of my tea. All right. See, now things don't want to work. Why is I have no idea why my PowerPoints, this is why I switched to the other program. Okay. All right, let's go down to the next one. All right. Sometimes we know the percentile, or we know the probability. We know something like that, but we want to find the data value that corresponds with that probability. Like, I know that my test score is in the 90th percentile, but I don't know what the test score is. I want to find that test score. I'm like, or whatever. Say like you take standardized tests now. Look, you scored in the 85th percentile. If I know the mean and the standard deviation, I can calculate that score. So we use an inverse function. We use it backwards. Okay. So the way that we can find the normal random variable, I can look at the Z or the table, and I can find the Z score that corresponds with that area. And then I can math it out. And I'll show you how to do that. Or I can use inverse norm. And it is a beautiful thing. And though some of you might have calculators that have the left, center, right feature, most people don't. So I'm going to teach it as if you don't have that function in your calculator, because only the most recently updated calculators have that. So I'm letting you know, mine might look a little different than yours. And so I'm going to teach it as if you don't have this special feature. Okay. So I'm going to ignore that and move on. All right. So the GRE is a test. It's normally distributed with a mean of 1049. Stop it. A mean of 1049 and a standard deviation of 189. I want to know the score a student got if it's in the 85th percentile. So I'm going to do it with z-scores first, and then I'm going to do it with inverse norm. All right. So I'm going to go to my Z table. Okay. 85th percentile. This is not the most efficient way to do this. Trust me. I'm looking in this vast sea of Z table, to find the closest value to 85. This right here, 0.8508, that is the closest value to 85. And I'm going to show you it on my screen over here now. So my closest value to 85, what did I do with it, is right here. Now I just cut my Z table to make it smaller to fit on this page. So I know that the Z-score then is 1.04. So I found the Z-score that goes along with the 85th percentile. Now, let me tell you, this is the long way math. I highly encourage you to use your calculator, but I'm just letting you know this is the thing. Okay. So the Z-score that I have, stop it. So the Z-score we got 1.04. All right, that's lovely. So you may recall we have a Z-score formula. I'm going to plug these values into that. So my Z-score is 1.04. We don't know the data value. I know the mean. And I know the standard deviation. Now I'm going to just use my fancy math, my algebra, to solve for X. Multiply both sides by 189.
Where did you get the 1.04 again?
I got it from my Z table because I looked for, so see how right here, this is really close to 85%. I just looked in the body of the Z table till I found a probability or an area that's really close to 85%. And then I found the Z-score that goes with it. So this is 1.0 and my hundredths place is 4. Does that make sense? Okay. What was that?
No, I didn't realize that's what the top 0.00 through 0.09
Yeah,
meant.
these are just the hundredths place, and our whole number and our tenths place are on the left column.
So just for example, if you were doing the one underneath, like 1.1,
Mhm.
and we're in that same 0.04, what is that?
1.14.
Got you.
Yeah. Are we good?
Yep.
Cool beans. Let me go back up. All right. I'm just mapping this out. I'm just out doing my algebra. I like some good old algebra. Stop it. So I have 196.56, trust me, equals X minus 1049. Add 1049 to both sides. I'm running out of room, so I'm not going to show that. So I have that my X value. I didn't do that right. 196.56. I think my grandchild got sticky stuff on my calculator. So I have 1245.56 equals X. Now, my guess is y'all don't want to do this much math. That's my guess. I'm guessing you would much rather use a fancy schmancy calculator and use a function right in here. I do love some good algebra too. Don't get me wrong. I'm a math teacher. Algebra is it's like my jam. But we would really like to just use the calculator. Let me show you. I'm gonna go back to my fancy schmancy calculator. I'm gonna clear this out just because I want a clean screen. So once again, go to second vars, and we're gonna go to inverse norm. So this is we're just working backwards. Most likely, you do not have left, center, right. So yours defaults to left. So I'm just only going to do it with left, because when it doesn't have left, center, right, yours is doing the left. So I'm going to pretend you don't have it. So we're looking for the 85th percentile. So I'm going to put 0.85 in the area. And I don't want a Z-score. I mean, I know the Z-score I'm going to get, but I don't want the Z-score. I want actual data values. So my mean is 1049 and my standard deviation is 189. And I'm putting this on left because that's the default. Most calculators don't have this left, center, right. So left is the default. So we're just going to go there. Go down to paste and hit enter. So if you don't have a calculator that if it just gives you the inverse norm and you have to put stuff in, ignore the left, just put 0.85 to put the area first, then the mean, and then the standard deviation. And I'm going to hit enter. And it's really close. The reason that it's different, so we have 1244.86. The reason it is different is because the Z table wasn't exactly 85 and it rounds. So since the Z table was 0.8508, it is slightly off. So this one is more accurate, 1244.86. I believe my open math takes into consideration using the Z table and using the calculator. Questions? All right, let's go back. There, it went through there, we went through there. It shows you the calculator function and all that right down here at the bottom. If it would let me write, that would be cool. So it shows you all the calculator stuff right down here. All right, let's do another one. So I would like you to try this one. The weight of giraffes are approximately normally distributed. They have a mean of 2,200 pounds and a standard deviation of 200 pounds. We want to know the weight of a giraffe in the 75th percentile. So go ahead and try this on your own. If you get stuck, sit there and look pretty until we go through it ourselves together. I guess I should do it so that I could get an answer. I'll tell you in a second what I get. I got whoops. Stop it. Weird things happening over here. Okay. 2334.898 about. 0.9 works. I like 0.9. 0.9 is probably a better number than 0.898. Yeah, 2334.9, perfect. All right. Do any of you have that left, center, right on your calculator? No, so we use inverse norm when we have a probability or a percentile or an area, and we're looking for data values or a Z-score. You don't? Okay, nobody has that. Okay. You use normal CDF when you have data values and you're looking for a probability or an area, or if you have Z-scores and you're looking for a probability or an area or something like that. So yeah, so I'll write it down. At the very end, I'm going to write it. I'll write it down. Maybe it'll help. I'll do that at the very end. Okay. So let's go to the next slide. So, not yet. All right. Sometimes I needed to ask that question because we're going to do a center, a middle, and that's going to make a big difference. So, because you are going to have some of these questions. So we know that the length of a certain steel rod is normally distributed, has a mean of 100, and a standard deviation of 0.45 centimeters. The manufacturer wants to accept 90% of all of the rods manufactured. We want to know the length of the rods that make up the, what the heck? Stop it. Stop it. The middle 90%. So we need the lengths of the rods that make up the middle 90%. So what we need to do, let me show you. I draw my curve. It's not a bad curve. The middle 90% is right in here. So we need to know what makes up this. You need to think about when you're thinking of the middle 90%, there is still 5% down here, and there is 5% up here. So let me tell you a little secret. These z-scores for right here and right here, if you're doing z-scores, they'll be the same. They're just going to be opposites of each other. But we're looking for data values, not z-scores. So what I'm going to do is I'm going to use inverse norm. Actually, if I go to the next screen, it's going to be there. You use inverse norm with 0.05. I don't want you to see this. I want you to see the answers. I know you already saw it. Inverse norm with 0.05 to get that bottom 5%, and do inverse norm with 0.95 to get that top 45 or top 5%. Let me show you what this looks like. I'm just going to do both of them. So do second vars, maybe. Why are you being mean to me? Okay. Second vars, go down to inverse norm. It's not being nice to me right now. Get rid of the second. Okay. So I'm going to do 0.95. And we have a mean of 100, a standard deviation of 0.45. You don't have the left, so I've got for 0.95, I have a value of 100.74. And then I'm just going to go up because I'm lazy like that. I'm going to paste it. I think I showed you guys this before that you can just paste. I'm going to change that to 0. Do you remember I showed you that? You can just go up and highlight it and paste it. And then hit enter. And I get 99.26. Oh my goodness. I've got weird things happening over here. Hold on. Good thing you can't see my screen. All right. Right. Exactly. So if you just use your arrows and go up to something, you can just, once it's highlighted, if you hit enter, it pastes it. And then you can go and change whatever the heck you want. That's when I changed that to a 0. I do it all the time when I make a typo because I make a lot of typos. And then you can just calculate it. It is like the coolest thing. Yeah, you know, viva la lazy. Okay. All right. So in the 99, these are centimeters. The rods that are between, that are in the middle 90% go from 99.26 centimeters to 100.74 centimeters. Your assignments will ask you to write them as an interval. I get a lot of questions every term that say, I got it wrong. They want you to put it in like this, parenthesis, 99.26, your lower values on the left, comma, your upper values on the right, and then put parentheses around it. This is how they're going to ask you to put it into your, into My Open Math. They're very picky. So they'll want parentheses, the lower number on the left, the upper number on the right. Questions? So this is the picture I already drew. I don't care about z-scores. It wants you to look at your z-table, find the z-scores. Yes. Well, you're only doing two. Yeah, you're only going to enter them like this for if they ask for, if they say middle, they want to know the interval where like the middle 95% are or something like that. That's when you're going to use those parentheses. It'll tell you to enter them like that. I probably have an example I can show you. Yeah. Okay. And this is just a picture. So it is what it is. It's just a picture. To show you exactly what we just did. I already drew this picture and mine was better. So I'm going to go over to the homework. I'm going to see if I can get an empty note here. Get an empty note and we're going to do some, hey, there's a whole bunch of math right there. Let's get a new note. All right. Go away. All right. So I'm going to go to the homework because there's a couple of, yeah, don't use homework. You got to use parentheses. Okay. I'm going to go over to my open math. And let me see here. I'm going to see if I can find an interval one, and then I'm going to show you the other one. Maybe not. They have an interval one. Yeah, so the interval, see, it wants it with the parentheses. Make this bigger. If you put brackets or you don't put the parentheses, it's going to mark you wrong. Okay. This is the question. Where is it? Where is it? Am I in the wrong one? No, this is the question, type of question I get the most questions about. So most students message me about one like this. I'm going to draw the picture and then we'll go over to, I'm going to draw the picture and then we'll go over to my notepad. It's not going to be beautiful. My picture is not going to look anything like theirs. Well, it will kind of. -1. I'm trying to make my picture pretty, just a second. Okay. I bet you all didn't know I'm a professional artist, did you? Definitely a professional artist. I mean, I'm getting paid to do this right now. So clearly I'm a professional artist. So, all right. See, isn't this beautiful? Isn't this just lovely? All right. So it gives you the middle. It says the shaded area is 0.3. Okay. So it doesn't look different. Yeah, I changed it. It was ugly and I made it better. Anyway, so it is the middle 30%. So these will always be the middle 30%. So the thing to know about it being the middle 30% is that the mean, whoa, weird things just happened. There you go. See, that changed. The mean is smack dab in the middle. So if this is the middle 30%, then there's 15% here and there's 15% there. Remember, this is the 50% mark, right? Therefore, what I'm going to put into my inverse norm is going to be 50% plus 15%. I'm going to put 0.65. And then 50% minus 15% is right here, 0.35. But this z-score and this z-score are going to be exactly the same, but the one on the left will be negative and the one on the right will be positive, just so you know. So if I put that in my calculator, put this in my calculator, second vars, I'm using, whoops, I want to go up one. I'm using z-scores, so 0.65, 0, 1, So the z-score is 0.385, which it'll probably, whoops. So the positive z-score is 0.385. The cool thing is the negative z-score is exactly the same. It's just negative. So you only have to find one of them. Just find one and make the other one the opposite sign. All right. This concludes our program for today, but I'm still on record. If you have any questions that you want for the good of the group, for everybody to hear, I'm still on record. You can go ahead and ask them.
Can we go over the ACT one? That one confused me. The ACT, SAT
Yeah.
scores, the equivalent part confused me.
Okay, let's see. I think it's high up. Was it down, not up?
It's supposed to have like 3 answers, and it's kind of one of the longer ones.
Yeah. Okay. So I'm gonna I know it's up here. I know it's here. I saw it. There it is. Okay. So so we have that gives us the mean and the standard deviation for, Clemente, you want to do another one of the ones I just did? Is that what you're saying? Okay, but I'm going to do this one first and then we'll go back. So, the mean, it gives us the mean and the standard deviation of both the SAT and the ACT. So what it wants to know is it wants to know the SAT score and the 26th percentile. That's pretty simple. Just use inverse norm, correct? I'm hoping that you guys can do that pretty simply, right? So just use inverse norm with the SAT things right here. So my SAT is 1094 mean, standard deviation of 200. So use inverse norm with 0.26 and these, and you will get an SAT score of that. The way you're going to find the equivalent ACT score is you need to convert the SAT score to a z-score. Or even easier, find the ACT score in the 26th percentile. That's actually easier. So I would use inverse norm 0.26 with the mean of 22 and the standard deviation of 5.2. And then, so you're still using inverse norm. You're just using these values instead, and that'll give you the ACT score. And these are equivalent scores. So I'm sure the third one is the one that's most confusing.
Yes, that one is
A
confusing.
student got a 1394 on the SAT. If you use, you might want to write this down, use normal CDF to get get the probability or the area under the curve to the left of the SAT score. Get that area under the curve and write the information down real quick here that I have, and I'm going to show you. So 1094 and 200, and then 22 and 5.2. I'm going to show you this because I think showing is going to be a little easier. Okay, so I didn't write down what the actual SAT score was. That would have been smart. Okay. I seriously have not a lot of brain power today for some reason. So I'm going to do my normal CDF to find the area under the curve to the left of that test score. So I want to know what is the probability of getting a test score less than 1394. So negative 1E99, 1394. My mean for the SATs was 1094, and the standard deviation was 200. So I hit paste and hit enter. I got my probability. So I got the area and probability. They're the same thing. So I know the percentile that this score is in now. The percentile this score is in is 0.933, etc. So you either write that down or you use your copy and paste to go up to inverse norm. I want this score right here in my inverse norm. 9. I need to do insert. Just a second here. 3, 3, 2. Okay, I'm gonna delete that. Oh, I deleted the whole thing. No, okay. Let me fix it. And go back. I just messed up. Sorry about that. 9, 3. I'm gonna hit insert to insert the rest of the numbers. 3, 2. I'm just gonna go out 4. And then my mean is 22. My standard deviation is 5.2. And then close it out. Close it out. Uh-oh. Sorry about that. That was supposed to be a parenthesis. Okay. So now I have the area that was under the curve for the SAT score. I'm using the ACT scores down here. So the ACT score that corresponds is the 29.8. That makes sense?
Yes, I got them right. Thank you.
Yay. Okay, good. Should be 29.8. Yay. Okay. So I'm going to, Clemencia, want me to just make one up? Because I don't think I have another one unless I probably could tell it to give me another problem. Back up here. I don't know if it'll let me give it another problem. Can I do that? Can I get a similar problem? It won't let me do it. I'm just going to make one up because I'm so good at making this stuff up. Okay. Let me erase all this stuff. I have to scroll. All right. I don't know what's going on here. Stop it. Okay. I'm going to do another normal curve. Here's my normal curve. I'm going to make up a number. Okay, so I'm going to say that we have the middle, shade it, because why not? So the shaded area is, I'm going to say 52%, 0.52. I'm making stuff up. Okay, so the shaded area is 0.52. Therefore, my mean is smack dab in the middle. So I have 26% here and 26% here. Therefore, the inverse norm that I'm going to do is going to be 0.5 plus 0.26. So I'm going to use 0.76 for inverse norm. That will give me my positive z-score and just use the same z-score but make it negative. I don't know what that is. Let me look. Because I'm curious. I can't leave a math problem unsolved, you know? When I do, I always have to go back and solve it because I'm crazy like that. All right, so my z-score, 0.71 approximately. So and then I would also have and negative 0.71. So you make the same positive and negative because they're mirrored. All right. Anything else for while we're still on the recording? You're welcome. Okay, I'm going to turn the recording part off. Here we go.